Hey everybody, it's Wednesday. How even are you guys? So here we are talking about acids again. I guess we're doing that every day now, huh? Gonna keep doing it every day. So we started with this. What even are acids? We learned that acids are salts, and all salts are a cation and an anion. But in the case of acids, the cation is always a hydrogen ion. So that's the only thing that makes it an acid, we're saying. And we said there's three categories of acids: organic acids, like citric acid and lactic acid and lauric acid. And we're not going to talk about how to name those because the name just is what it is. Lactic acid is lactic acid. So we're not even going to worry about it. Halide acids, we talked about how to name those last time. We said that you just chop off the suffix of the anion. So if your anion is fluoride, you chop off the "ide" and you replace it with "ic", and you call it hydro from the hydrogen, fluoric from the fluorine acid. Hydrofluoric acid. Yeah, that's good. So next we're going to talk about these polyatomic ions and how to name those. So hit the pause button if you haven't already and get yourself some paper so you can take some sweet notes on how to name polyatomic ion acids. Wednesday, April 29th. Okay, so let's see here. Let's go like this. So here's an example of a polyatomic ion acid where the polyatomic ion has a -1 charge, like nitrite or like what is that? ClO2 chlorite, like chlorite. So if the ion is nitrate or chlorite, then you'd only have one hydrogen ion here, 1 plus and 1 minus. Yeah? But if you had a polyatomic ion with a 2 minus charge, like for example carbonate, then you would need 2 hydrogens because each hydrogen has a 1 plus charge, and you need 2 of those to balance out the 2 minus charge of, for example, this carbonate ion right there. So that's the deal with acids made with polyatomic ions. They have as many hydrogen ions as they need to have in order for the salt to be electrically neutral, just like any other salt. Okay, so, Okay, so if you look at these polyatomic ions here, you'll notice something. Acetate, cyanide, hypochlorite, chlorite, chlorate, perchlorate, nitrite, nitrate, permanganate, carbonate, chromate, dichromate, peroxide. If you notice, almost all of them either end in "ite", like hypochlorite, or in "ate", like chlorate. Ate, ite, ate. You'll notice that almost all of them either end in "ite" or "ate. So they have a suffix or an end part of the word that's either "ite" or "ate". Go ahead, check it out. You'll see for yourself. So here's the way that we name the acids. If your polyatomic ion ends in "ite", then the name of your acid is going to end in "us", O-U-S. And if your polyatomic ion ends with the suffix "ate", then your acid is going to end in "ic". And I know that sounds really confusing and it sounds like you're not going to be able to do it, but believe me, you are going to be able to do it because you're a boss. So in summary, if it ends in "ite", you're going to change the name of the acid is going to end in "us", O-U-S. And if the polyatomic acid ends in "ate", then the name of the acid is going to end in "ic". So here's how I remember it. I don't know what you guys want to do. Here's just what I do. You do what you like. But I just go "itis, ate, ic", "itis, ate, ic", "itis, ate, ic". Idiacetic, idiacetic. And I just memorize it, kind of like you did with meth, eth, prop, bute, butanol, propane. Yeah, how many carbons there are. You just have to memorize it. You just do it, man. Just do it. It's all good. Idiacetic. So here's how it works. Check it out. Check it out. What if you have an acid with a formula like this? What's its name? Okay, well, the H we know is the cation. That's what's making it the acid. So we can just look at the rest, ClO2, and then we can look here on our list of polyatomic ions and find ClO2. There it is right there. So ClO2 is chlorite, is the name of the ion. So if the name of the ion ends in ite, like chlorite, then the name of the acid is going to end in us. So the name of this acid is going to be chlorous acid. No hydro. We're not going to put hydro like we did with the halides. When our anion was a halogen, we put hydro in front of the name, like hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. But we're not going to do that with these polyatomic ion acids. We're just going to change the chlorite to chlorous, and then we're going to add the word acid to the end to make sure we let people know we're talking about an acid. So the name of this acid is chlorous acid. What about HClO3? What's the name of that sucker? Well, ClO3 is chlorate as opposed to chlorite. It's chlorate. ClO3 is chlorate. So for 8, we turn the suffix to ic. So this is going to be chloric acid. Yeah, I know it sounds kind of confusing and they sound kind of the same, but you're just going to do a buttload of practice until you can crush it, and you're going to crush it just like you crushed everything else this year. Okay, nitrous acid. What is the formula of nitrous acid? So here we're going to have to go backwards because we're starting with the acid, and we're going to have to figure out what polyatomic ion is. So nitrous acid. So us came from an ite. So we need to look for nitrite. Nitrite is what we need to look for. And here's nitrite right here, NO2. And it has a charge of 1 minus. So we're only going to need 1 hydrogen ion. So it's going to be H. And then what was that? Nitrite again? Nitrite was NO2. So the formula is going to be HNO2 for nitrous acid, as opposed to nitric acid. Nitric acid comes from the nitrate ion. So just look at that root of that word, N-I-T-R, and then add 8, nitrate. So we just need to find the acid called nitrate right there, NO3, and the charge is 1 minus, which means we're going to need how many hydrogens? That's right, just 1. So we're going to say HNO3 is the formula for nitric acid. So I did these kind of confusing ones on purpose so you wouldn't have to run into them all by yourself. I'm going to give you guys practice with this today. And then Thursday, I'm going to give you mixed practice with all these. And then Friday, we'll do the quiz. Sound good? I miss you guys. And I look forward to seeing you again. Okay, bye.